Hey guys, so we are going to be thinking about a ratio. So when you hear the word ratio, you might have some associations with it already, you might not. The good news is that whether you know it or not, a ratio is really something very, very familiar. So technically speaking, a ratio is a comparison. Comparison. So it's just comparing two values. Do, do, do. So it's a comparison essentially of two different things. So you can compare different types of things. You could compare what we call a part to part, meaning I have apples and I have bananas. That is a part to part out of the fruit bowl, if you will. You could compare a part to the whole, so apples to all of the fruit in the bowl, or you could compare the whole to a part, so all of the fruit in the bowl to bananas. So the ratios below kind of describe some of these relationships, right? We can have 2 bananas to 4 apples, a part to a part. You can have 4 apples to 6 pieces of fruit. So there you have your part to your whole, right? There are 6 total pieces of fruit in the bowl. Or you can do a whole to a part, right? So 6 pieces of fruit to 2 bananas. So no matter the type of ratio that you're talking about, part to whole, there's different ways that you can write them. So there's sort of 3 different symbols that you can use to write them. So given quantity A, apples, if you will, and quantity B, bananas, if you will, the ratio of A to B can be written in 3 ways. One way is you can say A, or apples, to B. You can use this colon. Okay. When you say that colon, the way that you say it is with the word to. So you can also write it as a to, use the word to be. Okay. And finally, perhaps the most familiar, but you might not know it yet, is as a fraction. So a to b. Or you could write it with a slash looking fraction as well. Those are the same thing. So colon, the word to, or as a fraction. So if we use this diagram over here to the left, we're going to practice. We're going to write each ratio in 2 different ways. So if we want to do the shaded squares, 2, interpreted as a colon, unshaded squares, I'm going to first put the number of shaded squares. The order really matters. So shaded squares, we have 4, 8, 9, 10. So in this mystery box, it's no longer a mystery. We have 10 shaded squares. 2, well, how many unshaded squares? We have 4, 5, 6. Okay, this is not simplified, but it doesn't tell us that it has to be simplified. So we're not going to worry about simplifying it right now. So we could then say, all right, let's practice a part to whole. So we have unshaded squares. Well, we know that's 6. We already counted those. 2 total squares. Well, we had 10 plus 6, shaded and unshaded, so we know we have 16 total. Again, not simplified, but we're not going to worry about it. Total squares to shaded squares. Well, our total is 16, and let's practice writing it as a fraction this time. So we have 16 total squares to 10 shaded squares. And here we have unshaded squares to shaded squares. So we'll say 6 unshaded squares to, practice our final way, to our 10 shaded squares. So the data is there, how you write it, in the order in which you write it, and the symbols you use. You have some freedom in the symbol, but the order is very important. It very much matters. So here we're going to do an application. This is on your page. So if we know that we have, out of 75 total students, 36 buy their lunch, what's the ratio of students who buy their lunch? So we know that there are 36 who buy their lunch per the given information, to, right? So we can interpret that as a colon, to students who bring their lunch. Okay, so we are given the information of students who buy their lunch to the students who bring their lunch. So we need to subtract to determine. So I subtracted 75 minus 36, 75, because that's the total amount of students minus the ones who we know bring their lunch. And now it says, ooh, we need to simplify. So just like with a fraction, whatever you do to one side, you have to do it to the other to keep it equivalent. So I know I can divide both by 3 because of our divisibility rules. So if you divide both sides by 3, we get 21 on this